Alright, so the second stage in the exhaust system is going to be the particulate filter. The particulate filter is there to reduce the amount of soot and particulate matter that comes out the exhaust system. Alright, soot particles are formed whenever we have a mixture that's either too rich or too lean during the combustion process. So sometimes when we have a burning take place in the cylinder, we'll have rich zones and we'll have lean zones. Anytime we have that, we can form soot particles. And soot particles are extremely small. We're talking 50 microns or smaller, very small in diameter. And as our combustion process gets tighter and tighter, we have higher and higher injection pressures. The droplets get smaller and smaller, which in the end creates even smaller soot particles. So we have to have a filter to be able to collect that soot particles and burn them off. And within that soot particle, we have lots of different materials that make up the soot particle. Part of the carbon, the hydrocarbons, the sulfate, the sulfur and metal oxides, water, ash, oil derivatives, all these different particles are incorporated into the soot molecule itself. And those soot molecules themselves have got to be trapped inside of a filter. So any of these particulate filter assemblies themselves are not a through passage like a catalyst, they're closed-ended, which means all the exhaust passes through the filter media. There is no open end at the other end of a particulate filter. So it's set up to where any large particles that are larger than the filter media will get caught in the particulate filter. And just like the name implies, it's going to be a filter assembly that's going to catch the soot particles. As you can imagine, the filter assembly's got a certain capacity. You're going to eventually fill the filter media up completely full. Well, once the filter media is filled up completely full, you got to do what they refer to as a burn-off process. You got to remove those carbon spheres inside the particulate filter and burn them down. A good way to kind of think of this is think of it as like a charcoal briquette. You're filling the filter full of charcoal briquettes, then you've got to burn them off, and when the burn process is done, you're left with nothing but ash. So you're reducing the size of the carbon molecules down to a small amount of ash. Alright, so how else can we get the exhaust system temperature up high enough? Well, we can do a hydrocarbon supported regeneration, which means I can do a post spray of my fuel, dumping that fuel in the exhaust system. Remember we had pre-injections, main injections, and the post-injections. Well, the very last post-injection was an additional charge of fuel that's sprayed into the exhaust system. That fuel really doesn't burn in the combustion chamber, but it's being fed down to my oxidation catalyst. My oxidation catalyst is going to take that unburned hydrocarbon and burn it in the catalyst itself, which will act as a burner to actually generate enough temperature in the exhaust system to help warm up my particulate filter up to its light-off temperature where I can actually burn apart any of the carbon particles that are stuck in our particulate filter. And the last method, which really isn't prevalent in this country, is going to be additives that could be added into the diesel fuel. This is simply just an additive that helps bring the light-off temperature or the burn-off temperature of the particulate filter a couple degrees lower. And the third method is using an additive in the diesel fuel. This additive in the diesel fuel brings the ignition temperature of the particulate filter down a little bit lower to promote the regeneration occurring a little bit earlier. It's really not a supported system in the US, but just be aware there's really 3 different ways to force a regeneration. Alright, so how does the controller know when it's time to do a regeneration? Well, most of these systems will incorporate pressure sensors. They'll look at a pressure sensor before the filter and a pressure sensor after the filter. And we'll look at the difference between the two to determine whether or not it's time to do a regeneration process. Now, some of them have eliminated the second pressure sensor and they just have an internal mapping built inside the EDC controller to know exactly how restricted the filter is. But here's an example of looking at one of these pressure sensors. It's a typical differential pressure between points A and point B, or the point before the filter and the point after the filter. And the controller has some logic built in there. It knows there should be some restriction depending on how much of a load I put on the engine. So it can detect whether the system is full or empty or completely missing. So that way there's fault detection put in there if somebody decides to tamper with the particulate filter. It knows that it should build up a certain amount of back pressure. If I don't see that, I will set a fault code for a missing or a defective particulate filter.